Cabal. Hello, hello, hello. And good evening, my dear students. How have you been? I hope you're doing well in this vacations according to the Independence Day. Today, a few days ago, we prepared an introduction for the physics kinematic class. We were talking about quoting from the difference between the movements in the horizontal path, vertical path, and two-dimensional path. Well, actually, in the last video, we're solving a few exercises according from the problems using the uniform speed or constant velocity. Okay, what does that mean? That means the velocity will be the same and there is no acceleration. Okay, but this time we're going to try to solve problems. In this case, when what happens with the particle when moves left side or right side, applying the uniform acceleration. Remember the definition from the acceleration is the change of velocity be using a period of time. When the velocity passes from the smaller velocity to the highest velocity, we're going to say, this is going to be acceleration. But when this is the opposite, when we have passes to the greatest velocity to a smaller velocity, we're going to obtain a negative acceleration that we call deceleration, or simply worse, we are applying the brakes. Okay. As soon as we studied in the last video, in this uniform acceleration, we have four equations, okay? But sometimes in the problems in physics, this is not will be only enough to apply the formulas. We must to analyze the problems, especially when the question on the problems gave us a conditional problem. I mean a conditional situation, somebody speaking. Well, in this case, we're going to solve a couple problems to accomplish what we're talking about. This is not a kind of problem that only going to use, this is going to be the formula and that's it. Applying the equations, we're going to solve the problem. Now, where in this case, this is not a little complicated problems, but we must to read careful what the problem establishes. Okay, well, let's going to focus on the first example. Okay, in the first example, the problem says when we are talking about a train. A train is traveling down a straight track at 20 meters per second. When the engineer applies the brakes, resulting in acceleration of -1 meter per second square. Why? Because they're applying the brakes and obviously the velocity will be decreasing. That's why the negative acceleration. As long as the train is in motion. So we have a question. How far does the train move during a 40 seconds period time interval, starting in the instant the brakes are applied? Okay, so this is what we're talking about. Let's going to analyze the situation at the first try. For example, we said the initial velocity will be 20 meters per second. The acceleration will be -1 meters per second square and the period of time is 40 seconds. Okay, the first thing like a student we're going to analyze, it says, okay, we have three variables that we are looking for distance, and if we analyze the situation, I mean the four equations given, okay, the chosen one will be the second equation. Distance equals uh, 1/2 acceleration times square plus initial velocity and period of time. Okay, and you're going to say, well, it's simple, this problem. The only thing that I have to do is replace the values. I mean, the acceleration will be -1 meter per second square. The full period of time that will be 40 seconds at the second power, okay, plus the initial velocity that will be, in this case, 20 meters per second, and the last period of power will be 40 seconds. Okay, let's see what happened. 40 second power will be 1016 times -1, -1006, sorry, 40 a second power, 1600. Multiplied by -1 will be -1600 times 1/2, that will be -800 meters plus 40 times 20, 4 times 2, that will be 8. We can add a couple zeros, and we have 800 meters minus 800 meters, and the distance will be 0. Well, but you're going to say, but this does not make sense because they created a movement. Well, actually, this situation makes sense a lot as soon as you can imagine, because when this distance, that will be 0, that happens exactly when the time period interval reaches the 40 seconds, the train will stop. So in this precisely moment, the distance will be 0 units because there's not going to be any moving anymore. So well, the meaning of this situation is this 40 full period of 40 seconds is established exactly in 2 cycles of 20 seconds. Because if you read the problem once again carefully, the problem mentioned at the beginning, a train is traveling down a straight track at 20 meters per second. Well, in this case, the train is not traveling like a initial velocity or final velocity. In that period track, that means the train moves at constant speed. Well, in that situation, because we have exactly values, 0 units at the end, okay, that means the period time will be divided into exactly valid interval 20 seconds track. For that reason, in the first track, before to apply the brakes, we can calculate what will be the distance of the train at the beginning when it's traveling at 20 meters per second. So because it's moving at constant speed, okay, so we're going to obtain the distance will be, the velocity, sorry, will be 20 meters per second, and the period of time, we're going to use the first 20 seconds. And if we multiply 20 times 20, the first period of traveling time, that will be 400 meters. This is what happens at the beginning of the track, because this train is traveling at constant speed in the first 20 minutes. 20 seconds. And after the first 20 seconds, the last 20 seconds later, that complete the full period of time, well, the engineer says this is time to try to stop the train. So for that reason, the initial velocity in the train obviously will be the same, 20 meters per second, and we're going to stop the train in the last 20 seconds, completing the, the period of time of 40 seconds to obtain what will be the distance traveled, separation between in the event A until that event B. So if we're going to trying to looking for what will be the distance, that distance the train moves during the last 20 seconds at the moment they're going to apply the brakes, obviously the formula located in the blue one will be the same. But what will be the difference between them? Simple, instead to use a period of time of 40 seconds, I'm going to use only the second half, the last 20 seconds. So 1/2, the acceleration will be negative 1/2 meters per second square. The period of time will be 20 seconds at the second power plus 20 meters per second times 20 seconds. We're going to obtain, well, simple. 20 second power, 400 times negative 1, negative 400 times 1/2, that will be negative 200 meters. Plus 20 times 20, that will be 400 meters. For that reason, the distance between the moment they're going to apply the brakes, the last 20 seconds of the period of time will be given by 200 meters. So basically, what will be the answer for the problem? Well, how far does the train move during the 40 seconds time interval, starting in the instant the brakes are applied? Okay, in the instant the brakes are applied, well, it will be 200 meters. But if the question, instead to use In the instance the brakes are applied, the problem only said how far does the train moves during a 40 seconds time interval. If the problem ends until this part, uh, obviously omitting the last part when it says starting on the instant the brakes are applied, okay, the answer will be 600 meters since the beginning until they're applying the brakes and coming to rest, because the distance will be zero, the period of time will be zero, so the total distance will be 200. But because in this case the problem mentioned only at the instant the brakes are applying, the answer will be 200 meters. Every time that the problem, guys, we're going to apply the formulas in the problem, we must to analyze what does that means in the what they're asking for in every problem, because this is not only substitute or replace the formulas because we have only data, because if you're doing without analyze the situation, you're going to try, you're going to find out or this kind of problems or issues don't make sense, because there's don't make sense in 40 seconds. There's going to be a displacement, right? So basically, this is going to be the answer for the first problem. Okay, we're going to erase the blue one part, because the blue one part and the moment gave us zero. That means we're supposed to split the period of time into sequence, exactly two sequence value, the midpoint, as a man is speaking. That's why we are using 20 seconds in the first period and 20 seconds in the last period. Okay, so let's going to analyze the second problem. Everybody has a physical education teacher, right? In the college, even though in the university. And just to improve our performance, we have sometimes we have to approach some, how to say that, some dares to increase our performance. Okay. Well, in this problem, is see real life situation. Okay. That's happened to one girl around 20 years ago. Okay. And that was the situation. To pass a physical education class in university, a student must run 1 mile in 12 seconds. In 12 minutes. This is the requirement. So let's going to try the requirement to pass the exam. To pass the exam, she had to move a distance of 1 mile. 1 mile. In how long? In 12 minutes. This is the requirement that she's supposed to accomplish to pass the exam. That's supposed to be the total distance she has to move. Okay, that 1 mile, no more, no less than that. Okay, so what she is doing? Okay, her numbers. That's going to provide the situation, what she is doing. Her numbers or performance, somebody speaking, okay? After running for 10 minutes, okay, she's running. Obviously, she starts from reds at the beginning from the test, okay? And the problem asking saying, okay, she's running in a period of time of 10 minutes. Okay, and the problem mentioned after running for 10 minutes, she still has 500 yards to go. Okay, he still remain the distance remaining of 500 yards. Okay, if the maximum acceleration is, so the acceleration she's supposed to obtain is 0.15 meters per second square. So the question is, she's gonna make it, yes or not? She's going to pass the exam, yes or no? Okay, what is the situation according from her numbers? Because to pass the exam, okay, we must to clarify if she's gonna make it or not, because remember the maximum period of time that she's supposed to obtain, that will be 12 minutes. Okay, what is the situation? Okay, let's see what happened to A and B. Obviously, what is the initial distance? Because remember, in the first minutes, the problem mentioned after the first 10 minutes, she still have 500 yards. Okay, remember, we must translate 500 yards into meters. Remember, 500 yards, 1 yard, it has 3 feet, and 3.28 feet has 1 meter. Okay, this is we must analyze how many meters we're going to obtain in the after the first 10 minutes. Okay, we can cancel yards with yards, feet and feet, and let's see how many meters do we have. So we can multiply 500 times 3 and divided by 3.28. So we're talking about 457 457.32 meters. She's still remaining, right? And remember, the total distance he must cover, that will be 1 mile. And remember, 1 mile represents 1,609 meters. So let's go into, because we know what's supposed to be the entire distance, okay? 1,609 meters, and she's still remaining 457.32. Let's going to find out what will be the distribution between B and C. She still have to move 457.32 meters. Okay, to move from the point B onto the point C. And if you really want to know what's supposed to be the cover distance between A until B, it's simple. The only thing that I have to do is subtract the entire distance that she's supposed to cover, 1,609, subtracting the remaining distance, that will be 457.32. So the cover distance between A until B will be 1,151.68 meters. Okay. And if you add both quantities, gave us 1,609 meters. Okay. So if you see, we require a lot of information. So let's analyze. It's going to focus at the beginning of the problem, from the point A until the point B. That's why this is a conditional problem. She starts from constant speed. Constant speed. Because the problem says she's going to increase her acceleration after passes the first 10 minutes. So this is what the problem mentioned. For that reason, and from the point A onto the point B, she moved at the same rate of the speed. As a matter of speaking, the velocity in this case, that will be, well, actually, she start from rest, okay, but we don't know what will be the velocity she reaches. Well, actually, from the point A onto the point B, but we know what is the period of time, okay, and the distance, sorry, that will be 1,151.68 meters, and the period of time, we're talking about 10 minutes, because the problem mentioned it passes the first 10 minutes. Okay, you know, 1 minute has 60 seconds, 10 times 60, we're going to talk about 600 seconds. Okay? So remember, at the beginning, she started from rest, but the problem mentioned the maximum acceleration is 0.15 meters per second square after running the first 10 seconds after. So since the point B, the point B until the point C, this she's going to accelerate onto this part. I mean, that's going to create the schedule or the diagram, the problem. Accelerate. She accelerates from the point B until the point C. So basically the acceleration will be 0.15 meters per second square. And if you see, because we established since the point A until the point B, we have the constant speed. So the constant speed that we must looking for is the point A. Okay, that gave us the same velocity between the point B until the point C. So the first thing that we must do is trying to looking for what will be the value from that velocity. So for that reason, my dear students, the first thing that we must do is trying to looking for the constant of velocity. Remember the velocity that will be the total displacement divided by the total period of time. Okay, from A until B. Remember the covered distance, we established 1,151.68 meters. And remember the problem says when passes A until B, okay, that will be 10 minutes or 600 seconds. 600 seconds. For that reason, the velocity until the point A until the point B will be 1,151.68 divided by 600. So the velocity will be 1.92. 1.92 meters per second. This is going to be the cover velocity between A until B and B until C, because you're accelerating, the initial velocity for this woman will be given by 1.92 meters per second. Okay, she's gonna make it, yes or no? Okay, that depends on it. Remember, she passes already 10 minutes. He had only 2 minutes. To know if we're going to pass or fail the test, we have to looking for and what will be the period of time she's supposed to cover onto this part, okay? Because we had the acceleration, we have the initial velocity, and we are looking for what will be the period of time that she's supposed to cover. She's going to make it to cover a distance of 457.32 meters. We're using an initial velocity of 1.92 meters per second is 0.15 meters per second square. Well, let's find out that situation, okay? So, as supplementary words, we have the distance. Okay, we have the distance. We know what is the acceleration and the initial velocity. And I know if you're thinking we must use the second equation, you're right. The second equation establishes the distance will be equal to 1/2 acceleration times square plus initial velocity and period of time. Okay, so in this case, we're going to establish if she's gonna make it or not. Remember, the cover distance that's supposed to be 457.32 meters equals 1/2. The acceleration is 0.15 meters per second square times square plus the initial velocity is 1.92 meters per second multiplied by the period of time. I'm going to move the camera just a little bit to the right side. Perfect. Okay, and we can simplify this equation. And as soon as you can see, we have 0.15 times 1/2 that will be 0.075. So basically we have 457.32 meters equals 0.075 meters per second squared t squared plus 1.92 meters per second t. Okay, and if we are moving this distance as it passes the subtracting, we're going to obtain a quadratic equation that will be given by the following formula: 0.075 meters per second squared t squared plus 1.92 meters per second t, adding passes to subtracting, and that will be negative 457.32 meters. And this entire equation equals to zero, equals to zero. It's going to focus a little bit. Yeah, that will be equal zero. And we have this quadratic equation. And remember how we can solve this quadratic equation or quadratic formula. Remember the quadratic formula, we can solve it by means of the three methods. Factoring, but in this case, I'm not going to tell you do it by trial and error technique because we have decimal numbers and that will be so huge, complicated to solve it already. Okay, we can use the completing square technique or the classic, the quadratic formula. For this kind of physics problem, I strongly recommend to use the quadratic formula because in this quadratic formula, it was a most precisely solution. And actually, this is a known formula, okay? So in this quadratic formula, we have period time can be calculated by negative b, positive negative, square root b squared minus 4 times AC divided by 2a. This is going to be the quadratic formula. Okay, so basically the letter A will be the number who's next to the square variable. In this case will be 0.075. The letter B will be the number who's next to the linear variable. I mean 1.92. And the letter C will be the constant, the number without variable, that will be negative 457.32. All right. So the only thing that we have to do is replace those values and let's going to find out what will be the value from the period of time. But remember, guys, remember, because in this quadratic formula, always we're going to have two solutions, probably two positives, two negatives, one positive, one negative. Well, actually, 8 of 10 problems, we have one positive, one negative solution. But because we are looking for periods of time in physics, there is no negative values. For that reason, we're going to take only the positive solution. Okay, let's see. Let's find out the value from t. T equals negative b, because the formula, negative 1.92. We are omitting the units because that's going to be a little bit easier for us at the moment when to establish the calculus. Positive, negative, square root of what? B a second power. Again, 1.92 second power minus 4 times A, 0.075, and C, negative 457.32. The entire equation divided by 2 times 0.075. Okay, the real question is, how are we going to perform this calculus using their calculators? Well, simple. Let me show you a strategy how you can do it in your scientific calculator. Let me share the screen, guys. It's going to share the screen. Hold on a second. Okay, let's going to minimize All right. And we have this application for the scientific calculator. Okay. Let's see it. They're going to stop share again. Share the screen again. All right. We can have this application for the scientific calculator. Remember, we're supposed to solve that quadratic formula. So let's going to do it step by step because it could be a little bit harder to us at the moment to solve the part of the square root. So we can use the square root and we're going to open twice the parentheses, okay? And inside the parentheses, we're going to write 1.92 close parentheses, second power, minus 4 times a, that will be 0.075, close parentheses, open parentheses, negative 457.32. Close parentheses, the first one and second one twice because we're going to operate the entire operation inside the root. As soon as you can see, we are completing the square in this case. Equal button, and the answer will be 11.87 seconds. So we can copy the negative 1.92, positive negative 11.87 divided by twice 0.075, that will be 0.15, okay? And this is how you're going to perform the operation using the calculator, okay? Well, this is the moment of truth. Remember, there is two solutions, one positive and one negative. And because we are looking for periods of time, there is no way you're going to obtain negative answers in time because time is a scalar, not a vector. We can have a magnitude. Magnitude, that means the measure, but there is no direction. So time equals negative 1.92 plus 11.87 divided by 0.15. Remember, 2 times 0.075, that will be 0.15. Obviously, the first thing that we must do is perform the numerator, and after that, divided by that one quantity. 11.87 minus 1.92 divided by 0.15, the answer will be 66.33, 66.33 seconds. Okay, well, remember, the problem asking for is she passed or not the exam. Okay, let's see what we got. Remember, 60 seconds, we have a 1 minute. So let's see what we got. Well, we must divide 66.33 divided by 60 seconds. So we got 1.11 minutes. 1.11 minutes. So she is going to move 457.32 meters. Okay. With an initial velocity of 1.92 meters per second and acceleration of 0.15 meters per second over passes at the beginning. 10 minutes, okay. Remember, the requirement, she's supposed to pass the exam if and only if the period of time is equal or less than 12 minutes. For that reason, because she has a total period of 11.11 minutes, and this quantity is less than equal than 12 minutes. What does that mean? She made it. She made it. She passed the exam. She passed it. She will pass the exam. Okay, because 1.11 minutes is less than 12 minutes. Okay, and as soon as you can see, because she passes the exam, there's no, this is necessary to calculate the acceleration because the problem says if the answer is no, determine what this acceleration will need to be successful. But because according for her numbers, okay, she obtained 1.11 minutes plus the first minute she made it. He has 11.11 minutes less than equal than 12. So she finally passed the exam. Okay, guys, I hope you enjoyed this video. Well, if you see it's probably not always, it's just struggling. We're going to apply only formulas and values. We have to analyze the situation according to the problems. Okay, what is the real life situation? Okay, I hope this video will be helpful for you guys. If you like it, well, give me a like if you enjoyed this video, if it's for useful, and don't forget to subscribe and share the videos. In the next class, we're going to solving a few problems of vertical motion. This is what we call freely falling objects. So thank you so much for your attendance. Have a great, wonderful night. See you in the next class. Take care of yourself.